In this section, let's calculate the mean center and standard deviational ellipse. This will give us a better sense of the distribution and spread of tornadoes, windstorms, and hailstorms on this particular day. What is a mean center? Calculate it for the April 22 tornadoes. And here it is. I've labeled it with a T. The mean center, or the point at which the tornadoes would balance on, is right here, T. Let's do the same thing for wind. The wind center that day was over here on the Missouri-Illinois border. What about the hail? It is a bit southwest. So let's take a look at hail and find out why. Well, because there were quite a few hailstorms down here in southwest Oklahoma, and that pulled the hail mean center that way. In terms of wind, there were quite a few windstorms reported that day out here in Indiana and Kentucky, so that pulled the wind mean center over that way. Now let's calculate the standard deviational ellipse. Once I do that, for tornadoes, I have this oval. Inside this oval is one standard deviation above and below the mean. And so it encompasses one standard deviation of all of the tornadoes. You can see the shape, you can see the size. What about for hail? Hailstorms are more spread out, and so the shape and size is larger. Let's just take a look at the attributes here. We can see the area and so on, and the XY coordinates for the center of it. Excellent. What about for wind? The wind is even larger as far as one standard deviation, because the wind actually was quite spread out, as you can see here. We've got some wind all the way up into Ohio. Okay, well, interesting. Which phenomenon, tornadoes, wind, or hail, has the largest standard deviational ellipse? Does this match with what you predicted earlier? Then we're going to go ahead and save our map document. So by a couple of simple calculations, we have a better understanding of the distribution of tornadoes, wind, and hail. The next section of the lesson has to do with comparing one day of tornadoes to historical tornadoes. So we're going to go ahead now and just turn on the 1 day's worth of tornadoes right there. Excellent. Let's go ahead and turn off our base map here so we can just have a simple base map. If we turn this layer on, now we're seeing all the tornado touchdowns from 1950 to 2004. So does the 22 April 2011 pattern of tornadoes fit within the pattern of the historical tornadoes? Why or why not? Do some additional analysis on the historical tornadoes using the skills that you've learned in this lesson that you used on the 1 day's worth of tornadoes.